here. We are going to use any of the two screens, so you can watch Quentin on the back or in the front. It's going to be the same. So we are very happy to have Quentin. We are very sad to not have him here in person. Quentin was here, postdoc fellow before the pandemic, and we miss him very badly. And so we are very happy to have him talking to us about moving past the semantic conception of theories. Quentin, you have something like 40 minutes. Should I tell you when you have spoken by or 30 or?
Sorry?
You have like 40 minutes, half an hour. For how long do you want to speak?
Okay, 40 minutes. Okay.
Good. So you can start whenever you want.
Okay, thank you very much for the invitation. I'm very happy to talk to a UNAM workshop. I really enjoyed my stay in Mexico. And also, I'm sorry I won't be able to follow all the afternoon talks because it will be midnight here, so it will be a bit late for me to follow, but I hope to see them on YouTube later. So I'm going to talk about conceptions of scientific theories. So what is it about? It's theories are arguably one of the main products of science, and the idea of providing a conception of scientific theory is to understand what theories are, what they are for, what is their function, how they are related to other theories and representations, inter-theoretical relations, how they are related to models, to experience, and to the world. So it's really to provide some kind of framework to help make this kind of analysis. And originally, the standard framework was the syntactic view, what is now called the syntactic view, which is the idea that a theory is a set of general statements about the world. So a theory is a linguistic entity, and it follows that interpreting a theory, analyzing how it relates to the world, for example, is a question of linguistic analysis, in particular, according to Carnap or Hempel. It's a matter of making explicit the syntactic form of these statements through formal axiomatization, and then providing correspondence rules to interpret empirically the theoretical vocabulary, to relate the theoretical vocabulary to a vocabulary that is already interpreted. But this, as you're probably familiar with this, I'm sorry if you're already very familiar with it. So just to situate the debate, the semantic view came during the 50s, 60s in opposition to the syntactic view, with this idea that basically textbook statements shouldn't be identified with the theories. The theory are not the statements that you find in textbooks, such as the 3 laws of Newton. What these statements really do is they describe models. They describe abstract structures, which are extra-linguistic structures. And the way they do so can be captured by according to Suppers. I don't know how to pronounce these names, but Suppers in particular, this is captured by Tarskian model theory. So models are structures that satisfy the statements that you find in typical science textbook. But the theory is really a family of models. It's not a statement, it's what the statement describes, which are abstract structure. And then if you follow this line, then to interpret a theory is to provide some comparison, some relation between these models, these abstract structure, and real system and the world, basically. The motivation for this view are criticisms of the syntactic view. So there's this idea that comes a lot in the writing of defenders of the semantic view, that the logical empiricists were kind of lost in technicalities. It was the wrong level of analysis. We should get rid with linguistic analysis. Language is not the right focus. In particular, there is this idea that there are many ways of describing the same structures, and so we shouldn't focus on this way of describing structures, but on what is described. And perhaps the main criticism of the syntactic view comes with the notion of correspondence rules, which are thought to be too rigid for understanding what it is to interpret a theory. Because they rest on an irrelevant distinction, semantic distinction between two vocabularies, where they lump together heterogeneous aspects, such as maybe semantic interpretations, but also causal claims, claims about how measuring instrument function, and so on, or postulates. So they seem to lump many things that are heterogeneous. And these things can evolve without us thinking that the theory has changed. So, for example, experimental techniques can evolve, but we don't think that our theory about electrons has changed every time we find a new way to identify electrons, for example. But this is a consequence of the syntactic view, because you need correspondence rules to interpret the theory. So you need them to be part of the theory. So all these are well-known problems. And so the replacement proposed by semanticists is the following. So you have statements who represent theoretical models, who describe theoretical models. And then these are directly compared to data models, which are built from brute data that are extracted from experiments. And the idea is that all these aspects that have to do with technical abilities, all that I was talking about, technical abilities, causal assumptions, and so on, are somehow present at this lower level in the way that data models are built, and we don't need to account for it directly for interpreting models. Okay, so now I will review some challenges of this semantic view, and I will argue that we should move forward to something that is more pragmatic, as other people have argued as well. And then I will try to sketch a pragmatic conception of theories, which is something that hasn't really been done. So further challenges for the semantic view. Maybe the main challenge, the most prominent in the literature, is this idea that the semantic view wants to do away with language, with linguistic analysis, but it's not possible, it's unrealistic. So this is kind of presented as a dialogue, but of course it's fictional. But a first reproach that we could have against the semantic view is that theories are truth bearers. They can be true or false, just like a statement. But a family of model cannot be true or false. But of course, the semanticists were aware of this. And Geary, for example, talks about hypothesis. So we say a theory is a family of models. And it's also characterized by a set of hypotheses linking model statements and real systems. Then there is, okay, so far so good. But if you want to characterize this in purely structuralist term, maybe without using language, then the opponent to the semantic conception will say it's not possible, in particular because language fixes the domain of applications. You have models that have the same structure but applies to different things, and there are different models. You have models of electronic circuits and models of a pendulum that have similar structures, but they are not models of the same thing, and so they are not the same models. And to this, defenders of the semantic view respond that, well, Van Frassen in particular, in a recent article, responds that he never claimed. So Van Frassen is a defender of the semantic view, of course. So he claimed that he never claimed actually that language would could be completely avoided, that it would be silly to make such a claim, but that only fragments of language are needed, and in particular state description. So this is just to limit the extent of linguistic analysis and to focus more on structuralist analysis. But then another objection is that we need language anyway to describe the structures. We need something like set theory. And if we do this, then what is exactly the difference? What's the difference between presenting statements that describe structure or presenting these structures? In any case, what we are confronted with are just statements expressed in mathematical form, maybe. And in this regard, the main argument of the semantic view is actually an assumption that they had since quite a long time, that the syntactic view with its project of axiomatic formulation of theory is limited to first order logic. So the idea would be to give up the flexibility of mathematics, and to get the rigor of first order logic. But it's actually not part of their project. If you look at what Carnap and Hempel how they were presenting their view, Carnap, for example, was relying on type theory, which is just as expressive as set theory. And they often talk about Ramsey sentence, which is higher order logic. So there wasn't any such assumptions. So in the end, it's hard to say how exactly the semantic view and the syntactic view really differ. And a lot of people started to say, well, it's just a difference of attitude. It's a matter of focus. It's not really a deep difference. It's mainly a difference of focus. And in particular, the idea is to focus, according to Geary in particular, the idea is to focus on representation, to focus on models and on representation instead of statements and linguistic analysis. Yes. But here we come to something that is sometimes neglected, is what exactly they want to call a model, because they put much emphasis on model. And initially, Suppies claimed that the model of science and the models of model theory in logic should be identified. That's what his main article presenting, one of the first article at least presenting a semantic view claims, basically. The problem is that they're actually quite different. So a model in model theory is like the model of a painting. It's something that is represented by statements. It's what makes true or false the statements. Whereas a model in science is generally taken to be a representation, something that represents part of the world. So it's almost the opposite. And this is somehow acknowledged in Suppies' article, but he say, there is this common confusion between the theory, the statements, and the model, and so on. But and scientists themselves make this confusion. But we should identify scientific models with the models of model theory, the object of representation. Then Balzer and Moulines and other people of the structuralist program in Germany also acknowledge this difference, and they just say, scientists usually talk about models as representing, but for our purpose of reconstruction of what is theories, we will just employ the other notion of models, the logical notion of models. But Geary and Van Fressen take the other approach, which I think makes more sense if you want to respond to all these criticisms, if you want to really say that there is a substantial difference between the semantic view and the syntactic view, that it's not the same. You need this notion of model as representing something in the world. And then you can say, it's a difference of focus. We are focusing on representation by means of models of structure and not on language, and less on language. So, and that's what Geary and Van Frassen do. So Geary explicitly distanced himself from model theory in a footnote in Science Without Laws. And Van Frassen, it's a bit different. He said that basically a model can fulfill both roles, can be at the same time represented by linguistic statements and represent something else in the world. So there is this mediation role, which precisely is something that became important in some analysis of modeling practice in science. So precisely, if you want to focus on representation, I think there is a second challenge for the semantic view, which is starting from the 90s, a lot of people started to analyze modeling activities with this idea that models are autonomous agents. More particularly, Nancy Cartwright explained that scientific models must postulate concrete realizations of abstract concepts. So, for example, a Newtonian model must specify a force function. Newton theory just say that force is mass time acceleration, and there are stock models that specify force functions, but in general, it's more to build a model for concrete phenomena. You can rely on stock models to give you patterns, but according to Cartwright, it's not like a recipe. It's much more complex. Building a model is an art. And the same goes in quantum mechanics with the Hamiltonians. What you need is auxiliary theories. For example, if you want to describe superconduction phenomena, for example, you need theories that metals are lattices of ions. You need empirically motivated assumption that ions shield the electromagnetic field, so you can simplify things. You can sometimes have ad hoc assumptions, phenomenological laws that enter into the picture. And also, approximation techniques and so on. Okay. Are you still there? It's just that I have no feedback, so it's a bit okay. Good. I was worried. Okay. So yeah, there's this second challenge from that comes from pragmatics. That is that models are more than mere law-satisfying structures. So if you want to explain what a model is in science, if you take the side of logical model theory, you will take models to be just law-satisfying structures, so structures that makes true some statements. But if you want to focus on representation, you need to say a bit more. Models are not just mere law-satisfying structure. In particular, they denote, they represent phenomena of interest, something that can be addressed by the inferentialist conception of representation that Ottavio was talking about, for example. And then there is a problem, which is, can we systematically account for how models represent at the theory level? Can we say, in a systematic way, this model represents that because it has this and that structure or whatever, and it represents this in this way. This is what makes the model true or false, and so on. And in particular, we should make a difference between what the model represents and how it represents it if we want the model to be potentially a misrepresentation, which has been taken to be an important criteria for representation in the literature on scientific representation, that in principle, a model can misrepresent what it represents. So you must be able to make a difference between what the model purports to represent and what it says about what it represents. And the second can be false, while the model still represents. So the question is, can we account for all of this at a general level of the theories? And if we do, it seems that we are back to the syntactic view and to all its problems, and in particular, the problem of experimental techniques evolving independently of the theory and that kind of troubles. But if we cannot, then models, which is more likely, then models have some autonomy with regards to theories. They constitute two distinct levels. Theories are more general, and this is a conclusion that I didn't put the reference, sorry, that Margaret Morrison reached, that we should think of theories and models as two distinct levels. Theories are very general statements, and models are something else. And more or less the same conclusion is reached by Nancy Cartwright. Well, she doesn't take theories to be general statements, more like tools for model construction, but they're the same idea, that there are two distinct levels. And so the trouble is that if we want to escape the first challenge by focusing on representation, then it doesn't work as well as expected, because then models appear to be more autonomous that we could wish for, and we have to distinguish them from theory. So all this calls for developing a pragmatic conception of theories that could supersede the semantic view. And that's what I want to sketch here. So it's kind of a programmatic talk. Everything is not very well developed. It's more like a project that I want to sketch of what could be a pragmatic conception of theory. The problem is that a lot of people have this kind of idea that the semantic view is not completely adequate for the reason I just gave, but they don't really propose an alternative. Some people mention a pragmatic conception, but it's mostly defined negatively as what the theory is not. It's not purely formal, for example, things like that. And so the question is, can we be more constructive? And I think there are some desirable features that we would like to have for a pragmatic conception of theory. We would like to have a non-trivial notion of theoretical truth or acceptability. So the idea that a theory is about the world, basically, it's not a pure abstract calculus, and that it can be true or false. It makes some kind of claim. And the pragmatist would tend to associate truth and acceptability, to not make ideal acceptability, to not make a strong difference between the two. Then it seems that we need to retain this idea that models mediate between theories and the world, that to interpret a theory is not just to interpret a linguistic statement, but that somehow models play a role in interpretation. And then we should also retain this idea that representation by means of models depends on intentions, on context, and on practical abilities, maybe on experimental abilities, which are typical pragmatic themes. So I will start by focusing on models, how model represents, and present some things that I developed in my past research about representation. So we can start by fixing our ideas by taking some examples of models. A model of experiment, for example, would be a kind of model that could be involved in this mediation process between theories and the world. For example, a model representing a cylindrical piece of mercury cooled at controllable temperature. So, for example, with liquid helium and plugged to a voltmeter. with some finite degrees of precision, maybe in the way the apparatus can function. We could even associate with this model some data that were extracted from an experiment. For example, association between temperature and tension in the piece of mercury, the conductivity, and so on. Which would be more like a data model than associated with a model of experiment. Then we can think of a physical model, which is more abstract. It would be, for example, a lattice of ions at distance t with valence electrons and associated wave function. We can think as well, in order to be able to talk a bit of models outside of physics, we can think of a biological model, which would be a population of individuals in an environment and an associated distribution of traits. So how can we capture in a very general and idealized way what is a model, what they have in common? I think we can, yeah. So of course it's kind of an idealization, but the idea is that a model can be identified, roughly speaking, the content of a model be identified with the description of a configuration of entities of specific kinds with fixed characteristic. So this fixes what is taken to be the targets, what I call the target situation in the diagram below. This is what is taken to be fixed by the model. That cannot change, otherwise it's not the same model. It's not a variable. And then you have dynamical properties. For example, in our example from before, the temperature, the tension around the mercury, the piece of mercury, which would be dynamical properties. And this defines a model space, which can be represented by a kind of partition of possibilities. This is a partition because there are properties that are irrelevant. If we have a model of, for example, the color of the voltmeter doesn't really matter, only the display matters. And then we can characterize the content of the model, at least if we associate, in the case of models of experiment, if we associate the data with it. For the sake of generality, we can associate with the content of a model as well some valuation of the model space. The idea that some of the possibilities that are described by the state space of the model, by the some of the combination of dynamical properties, some specific values of temperature and tension are incompatible. These cannot happen. This last part is what the model says, where the two first parts are more have to do with what the model is about. Okay. So this is something I kind of developed in my earlier work in my book Model Empiricism, notably in chapter 3. This kind of ideas, and then we can consider, what it is to interpret a model. And we can think of it as a mapping between regions of model space. So the model space just given here, we take regions of this and we map it. If it's directly interpreted, this means that it's interpreted in terms of procedures and observations, which can rely on experimental abilities. It's not something formal. So direct interpretation is informal. That's the idea. And we can take the model to be accurate if it correctly describes what is objectively possible for us to do and observe in representation and situations of this kind, of this situation or situation of the same kind. And then in order to get to theories, we need to go up the ladder of abstraction. And the idea is to do so by means of a notion of indirect interpretation. So roughly this idea, the idea that instead of mapping regions of model space from the model to observations and procedures and so on, we will map it to another model, which is more concrete, which is supposedly more concrete. For example, we will we'll have a model of the, so here the middle level would be a model of the experiment. Sorry. Boop, boop, boop. Yeah. Involving a superconducting material, mercury, a voltmeter, liquid helium, for example. It's interpreted directly in terms of observations and procedures, experimental procedures. But the piece of mercury itself is itself represented by a more abstract model, which is a lattice of ions, a wave function and stuff. And we can interpret part of the regions of the model space of this abstract model. For example, a model space that would correspond to some value of the kinetic energy of the ions to a given temperature. So we have an association, a mapping between an abstract model and some regions of the model space of the abstract model and some points or maybe region as well of the more concrete model, of the model space of the concrete model. And then the idea is that the abstract model is accurate if it matches, there's a match between the possibility space, which can be a matter of approximation maybe. Yeah. So, okay. And then now we have almost everything to have some kind of pragmatic conception of what a theory is. So the idea is that a scientific model is some content. So what's happening? Yeah. Some content. So basically a state space with evaluation of the state space and indexical interpretation rules. Which are basically systematic rules of interpretation. The idea that a model cannot be interpreted in ad hoc way, in one situation, in another way, in another situation. The Lotka-Volterra model, for example, is a prey-predator model. It should be interpreted in terms of prey and predators and not electrons or whatever, or planets. So this is the idea that there are rules that, given the context, tells you how to interpret correctly the model, which is enforced at the communal level. It's by norms of representation. And this defines what the model is about. And so if we have this at all stages, all levels of abstraction, we can take a theory to be some kind of very abstract model, or maybe some kind of model space, a function from configuration to model. So something that tells you if you have this kind of configuration of ions, for example, then you should have this kind of model. And we can understand the acceptability or the truth of a theory as the idea that all acceptable interpretations of all models are accurate. So we have to basically go down the ladder of abstraction until we reach some experiments. And we can have modalities involved as well here. The idea that it should be accurate in all possible situations. This idea can be involved as well. So this is, sorry, I put acceptability, but this is ideal acceptability. So that's a kind of, basically that's a programmatic presentation of a research project. So, and I think it has some advantages when it comes to I think this kind of programmatic view of theories can have several advantages. First, well, we can have this idea that sublayers evolve independently of the theory itself, because roughly the theory will be a kind of model space. So you have a space of models, but at the level down there with models of experiment, different parts can be modeled by different theories, and you have some kind of autonomy that correspond to scientific practice. And yet the theory still has a domain of application. It can still be falsified or face anomalies. I think that the modality involved and the unification involved can account for explanations that there could be an account for idealizations as well via the idea of coarse grains, model spaces, and the idea that when you map coarse grain regions of model space, you can leave out some details of the models, which kind of similar to what Ottavio presented. And then you have this notion of autonomy of models and of modularity, that a model can combine different theories, that it can incorporate various modules in a creative way, there's an interesting article by Darigo which defends this. And we can also have some notion of ad hocness. Well, I think it can address basically quite a lot of issues that have to do with theories, models, representation. That's the conclusion, that it has many advantages. And that's it. Thank you.
So you can hear us, right? Martin? You can hear us?
Maybe not.
Sí, pero nos escucha, ¿no?
You muted Maria, is that normal?
I am that Maria, yes. But he should. ¿Nos oyes? Haz la cabeza como que sí nos oyes. So, Quentin, please.
So Quentin, can you hear me?
Yes, I can hear you.
Okay. Yes. So, well, I'm sorry you're not here. It's odd to come to Mexico City and you're not here. So I have to go to Lisbon then. Well, thanks for the talk. It was great. I think I really like the account you're developing on the second half. Right? I'm not persuaded by the motivation in the first half, because I think the critiques you offer, people in the semantic view have defended and have already in a way addressed some of those concerns, right? So Stephen has his own account of representation that would explain how models represent in terms of mappings, and Van Fassen has his whole story about that, including how representation include intentional elements. So I think sophisticated versions of the semantic view will address that. So maybe instead of motivating your view by those things, right, you may want to see, look, there's something else that is missing in their account that you can account for. And then you zoom in on those elements, right? Or if you don't want to motivate, you just offer your account, right? Because I think there are very interesting things in it, right? And that are worth developing independently of the motivation. Say, look, here's something that can address at least a somewhat principled reason to think about ways in which models and theories might be connected in a clearer way, right? So I like the way you're thinking about the model space, right? The idea of theories having this different range, right? Depending on the kind of area of the space that you're considering. I think those are quite interesting ideas. one thing that was not clear to me is the account of acceptability and truth, right? When you say all acceptable interpretation of all models are accurate. I'm not sure if you mean that normatively or descriptively, right? Because it seems to me very, very strong, right? We make models of theories of variety in all kinds of ways. And you may have all kinds of models that are completely inaccurate, right? Even though the theory may be actually in the relevant way for the other models that you might be interested in. And that's one of the features of the theory. If you say, no, every model of the theory, that's every model of the theory that has those acceptable interpretations have to be accurate, then you're going to have very few theories, right? And in fact, one of the interesting features that models have is exactly the plasticity. You have a variety of them, and you can pick and choose, right? As long as you have one model that accounts for what it's observable, right? That will do the trick. But if you require all, my worry is that you're not going to have any theories satisfying that worth its name. Okay.
Okay, okay. So for the first point, yeah, I'm aware of all these responses of Van Frassen, Stephen French, and so on that have this. But so I think the problem is that if they do that, they cannot at the same time maintain that a theory is a family of models. So it stretches the view a bit too far from the original idea of the semantic conception of theories. And they need to restore a proper place for theories that is distinct from the place of models. They need to accept that there are two levels. That's the important point, I think. So, but Geary goes a long way in this. Geary, for example, is very pragmatically oriented, and I think his semantic view is some kind of pragmatic view. So, and then, yeah, well, maybe it's a terminological issue, whether what you want to call the semantic view, the pragmatic view, at what point so, yeah.
No,
and regarding...
Neither says that theories are families of models, right? He's very clear about that. He says, look, only if you want to ratify theories, right, you identify with family of models, but he doesn't ratify, he's an empiricist. Right? So
Van Frassen is actually quite... I mean, if you look at his... there is an annex in his book from 2008 on representation where he discusses all these pragmatic philosophers claiming that models are autonomous. And he says, well, yeah, but we're just looking at things from a different angle. You're looking at the process of model construction. I'm looking at the ideal final product of this construction. And the ideal final product should satisfy exactly the theoretical laws. So these should be models of the theory in the sense of logical theory. So he defends quite strongly this idea that theories are families of models. And I think there is a tension there, but yeah.
If you look at what he says about theories and laws and symmetry, right, in the chapter on the semantic view, right, he's very careful not to identify that.
Not to identify, but to still characterize by a well-defined set of models. Yeah, maybe it's not an identification. Yeah, that's right. Anyway, and as for the second aspect, so yeah, truth acceptability, I take this to be a normative notion, an ideal notion that is supposed to capture what science is after, what would be an ideal scientific series, and so it can look very demanding, but if you think about it, with this notion of interpretation and these, which allows for coarse graining and maybe idealizations and stuff, maybe it's not that demanding.
Yeah, no, my only concern is that you require for all the acceptable interpretations should be accurate.
So the So the acceptable interpretations should be something like they could, I think, well, in my view, they could include stuff like, oh, this is for example, a frictionless model. This model should be only applied if friction is small enough, something like that. So it's not acceptable to interpret a frictionless model in terms of say a pendulum where there is a lot of friction. It's not, or you have to have a very coarse-grained notion of outputs, or maybe well, I mean, there are details to think about there. But that's how I'm thinking about the notion of acceptable interpretation. That I think that it's kind of part of. I completely agree with what you said earlier about again the holistic view, and I think it's part of what scientists do to say, look, this is idealized. You shouldn't take this seriously. The pendulum is a point. Yeah, of course it's not a point. Teachers say that in class. It's not. Of course it's idealized. It's not true. What is really interesting is the prediction of the position, not other aspects of the model. And so I think I would like to make all this part of the notion of an acceptable interpretation, basically, which could make the idea less demanding in the end.
Thank you. Great talk.
Thanks, Ottavio. Axel?
I also like all this a lot, like usual. But I wanted to see exactly what role or how committed you are to the indexical view. Because you call this a pragmatic approach, right? And I think there are a lot of pragmatic approaches to representation, right? And indexicalism is like the most weak or moderate or like not very hardcore pragmatism, right? Like that's the least pragmatic you can be is to be an indexicalist, right? So I want to know whether this is more like a placeholder for some pragmatic process, or you're really committed to the idea that the way they represent is through rules of interpretation that are as rigid as the ones for indexicals, or it's just that.
So. That's a good question. So the indexicality is one aspect that is pragmatic. I also think that the focus on experimental abilities is another part that could be considered pragmatic in this view, that at the end you have something like practical abilities that are not necessarily formalized. Then whether rules are strict or not, so again, so this is itself a model of scientific theories. So it's idealized in the same way that models are idealized. So of course, maybe rules are not always very strict, but yeah, I guess we could take it as some kind of ideal anyway. That ideally you could, if the stricter the rules are, the better. You shouldn't have problem if you are more explicit about how models should be interpreted.
Good. Thank you. That's very helpful.
Yeah.
Thank you. Anybody else? If not, I have a question. Yeah. So I have a question about how do you view the idea of possibility space for procedures and observations? Because it seems very peculiar that you didn't take available or something like that as a word for describing what you meant by procedures and observations. So what counts as a possible procedure and as a possible observation? Something that is sensible, but we don't have it yet, or for accuracy, right? So that accuracy is the intersection of that and something else, like a mapping between regions of the model space.
So yeah, so that's a good question, and what I'm thinking of is basically if you have a model of experiment, so you have your mercury, you have some apparatus, you can have models of how they function, but roughly, if you stay at the superficial level, the idea that experimenters would consider that they have a space of possibility for how to tune their apparatus. For example, if there's a button with just a finite set of indicator for the value of the tension in volts, they can think of a finite set of possible actions which correspond to adjusting the voltmeter or something like that, or the temperature, or, yeah. So, but yeah, that's certainly something that could be refined, I guess. I'm not sure if that responds to your question.
You were thinking when you said that, but thank you very much, Quentin. Anybody else? If not, let's give a round of applause to